Alright, so let's go ahead and start talking about simplifying radicals. Alright, so we've got a couple of different radical expressions. I'm just going to ask you to simplify. There's a simple way to do this. You want to look at this as you want to break it up into something that you know versus something that you don't know. So for example, this first example I have an index of 3. So I'm looking for a cubed root of something that I know. So you always want to think about the things you know. So let me go ahead and over here on the side write up the things that I know without my calculator. The cubed root of 1 is 1. The cubed root of 8 is 2. The cubed root of 27 is 3. The cubed root of 64 is 4. The cubed root of 125 is 5. So these are the type of things that you want to be able to write down as a way of kind of a point of reference. So those are the things that you know. So we're going to try to somehow break up 135 into something that I know versus something that I don't know. So you go ahead and take out your calculator and start figuring out what goes into 135 evenly. 135 divided by 8, or 135 divided by 27, 135 divided by 64, and so on. And what you're going to find out is that 135 is 27 times 5. That's how you can break that up, because when you plug that in, 135 divided by 27 gave you 5. So I broke this up into the 27 and the 5. All right. You want to think about this as what you know versus what you don't know. So I like to underline the things that I know. Kind of just makes it easier for you to visualize so you don't end up forgetting something along the way. So I've underlined what I know. So what I know is the 27. The cubed root of 27, we already know, is 3. So what you know goes on the outside. What you don't know is going to stay on the inside. So the 3 came on the outside, again, because the cubed root of 27 is 3. Now, for the 5, we don't know the cubed root of 5. So that actually has to stay inside the radical with the exact same index. The index does not change. Okay. All right, so we've ended up with 3 times the cubed root of 5, and that's how we break that up. All right, so I'm going to go ahead and do the same thing with that next problem so we can get a couple different practice, and then we'll throw in the variables. I'm asking here for the square root of 45 to simplify this radical. Again, I'm going to break it up into things that I know versus things that I don't know. So I can go ahead and list up a few of the square roots that I know. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4, and so on. We can go forever. Those ones I feel like maybe you should have in your head a little bit fresher in your head than maybe the cubed roots, because you use those more often. So you're going to break this up into the things that you know versus don't know. So again, it's 9 times 5. 45 is 9 times 5. I like to underline the things I know so I don't forget it. So the square root of 9 was 3. Again, here my index was that imaginary 2. 3 squared was 9. So the square root of 9 was 3. The square root of 5 you don't know, so it stays inside the radical. Okay, so that's the idea of simplifying radicals. Now let's go ahead and make that a few steps harder. Throw in a couple different variables, being able to break up the radical into things you know versus don't know. So let me do another problem. I'm going to talk about the cubed root of 40, x to the 8th, y to the 7th, and then z to the 9th. Simplify this radical. This is what I would like to do. Still simplifying. I'm talking about cube roots now. Always identify what your index is. Okay, so but before I even start simplifying it, let's go back a step. Just over here on the slide, if I were to give you just the variable cubed root of x to the 6th, this would become x squared. Okay, and what we just did is I just did the 6 divided by 3. So with the exponents, it's that division. X squared, and again, let me write that here, because x squared to the power of 3 is, in fact, you multiply those exponents and you get x to the 6th. Okay. All right, so we do need to care about those exponents on top of the variables. So let's go back and look at this problem that I have. Let's start with the number 40. 40 can be written as 8 times 5, and the reason I chose that is because I know the cubed root of 8 is 2. So again, breaking it up into things you know versus things you don't know. Then I'm going to deal with that x to the 8. X to the 8. Now 8 divided by 3 doesn't work evenly. So I need to have it look like something that can divide evenly. So if I break that up into x to the 6th and x squared, this I would know. just like what we talked about over here, the cubed root of x to the 6th. Well, that divides evenly. I would be able to do that no problem. And the same thing with the y. So the y will have to break up into y to the 6th and a y. Again, there was 7 y's, so I broke it up into 6 y's, and then the leftover 1. Again, cubed root of y to the 6th will be the something that I know. Now, z to the 9th, take a second to think about it. Is z to the 9th going to have to be broken up at all? And the answer is no, because the cubed root of z to the 9th will already know, because 9 divided by 3 works evenly. Okay, so I like to just copy it down. Some of you may want to skip steps along the way. That's fine. Okay, completely up to you. I just like to copy it down. I've underlined all the things that I know, so now I'm going to go ahead and take the cubed root. Cubed root of 8 is 2. Cubed root of x to the 6th is x squared. Again, 6 divided by 3. Cubed root of y to the 6th would be y squared. Cubed root of z to the 9th would be z to the 3rd. Again, 9 divided by 3. And then the things that you don't know, the things that weren't underlined, have to stay underneath the radical. So in this case, that was the 5, the x squared, and the y. So that is the simplified radical, breaking up what you know versus what you don't know. Ta-da!